So, hello, good morning, everyone. This is Joseba Bilbatua speaking. I am the Smart Cluster Director. I'm very pleased to be here and present you our Smart Cluster. So, as I said, good morning to every one of you. Good afternoon to our colleagues from South Korea that are attending this event. And a special thanks to our attendees from Canada, as it is 4 a.m. in Canada now. A special thanks to you all also for attending this Smart Cluster on Advanced Manufacturing event. So as you may have seen, the agenda of the event is will be quite short in the sense that we won't extend the duration of the webinar too much. It's expected to last 1 hour and a half. And first, I will introduce the Smart Cluster on Advanced Manufacturing, just to set the scene and the basis of what is smart, what kind of projects we expect from you to be presented in our call, and also to introduce the procedure on the Smart call in this fourth call. Afterwards, Aritz Arteche, the program coordinator from Smart Cluster, will introduce the procedure of the webinar, as well as the pitching session and the opportunity to interact with the speakers through the B2Match application. So saying that, let me start with the presentation, okay? So as I said, I will introduce briefly what's the Smart Cluster on Advanced Manufacturing about. Just to let you know all how this Eureka instrument is running. Okay. Okay, so first of all, the Eureka program is intended just to support activities and projects, international projects, which have these four main characteristics. The first one is that these projects should be or must be market oriented. So in the case of Eureka cluster projects, in the case of Smart also, we are not supporting very basic research with a low TRL level, technology readiness level. But what we expect to have is projects close to the market, close to the future exploitation and implementation of manufacturing technology into the business scenarios. And secondly, the projects have to be innovative enough, have to introduce new products, processes, or service associated or along with the manufacturing technologies. Of course, all the projects have to be bottom up. That means that we are not fixing the topic or the area that the project should cover. But the idea is that the companies, the entities, small medium enterprises, large enterprises could define the projects according to their needs, to their expectations or their priorities. So we follow always this bottom-up approach. It's not topic-oriented, but this bottom-up approach. And of course, all the Eureka the funded projects have to have an international dimension. So you will see later that there is a minimum eligibility in terms of the number of countries involved in the Eureka Smart Cluster projects. Okay, so within the Eureka instruments, there are many different kinds of instruments. One of them is the Eureka cluster projects. And from these cluster projects, these are the 7 Eureka clusters that are active nowadays. Most of them, some of them are dealing with a different kind of technological scope. We have clusters dealing with telecommunications, electronics, energy, materials, or even software-intensive systems. And we have Smart, the advanced manufacturing, is a focus on advanced manufacturing processes. I have to say that we are focused on discrete manufacturing instead of continuous manufacturing processes, as you will see later. Okay, and this is the Smart, the clusters, Eureka clusters running nowadays. So let's go to the focus and to the point on Smart advanced manufacturing. So our mission, of course, is just to contribute to the competitiveness, growth, and attractiveness of the manufacturing sector worldwide, not only in Europe, but we are working with the Eureka community. And you know, Eureka has members from worldwide. We have Canada, we have Chile, we have South Korea, Turkey, Israel, Norway. And we have partners and countries from different from the worldwide. So basically, these are the supporting countries that are contributing or that are supporting a smart cluster on advanced manufacturing. So these are the countries that have confirmed the interest of their national public agencies and the priority of advanced manufacturing within their national priorities, and allocate funds and budget and programs to support the participation of their entities into smart cluster. Okay, so from these countries, you can find partners to set up your projects, consortia. And you will see later that there is a minimum of at least 2 industries from 2 of these countries to be engaged in our projects. So let's go briefly on the technical domains that we have defined from smart advanced manufacturing. To be, let's say, the projects have to have some relationship with some of these technologies that I will explain a little bit now. As you will see, we are following a very transversal, horizontal approach to the advanced manufacturing technologies. We are covering all the manufacturing technologies that could be of the interest of the industries nowadays at short term, but also at medium, long term. But in order to distribute or to structure the strategic research agenda, we have defined these 6 technical domains. So in the case of the first domain is the advanced manufacturing processes. We include here all the conventional and non-conventional manufacturing processes for subtractive, additive manufacturing, laser-based, or any other manufacturing related process. Also, those technologies oriented to work with new materials or to introduce, for example, new functionalities into the components because they are affecting the surface or are introducing new properties to the components. So in this domain, we are including the advanced manufacturing processes in general. Second domain is dealing with the advanced manufacturing systems. Here we would include not only machine tools, capital goods, but also all the robots, manipulators, measurement systems, quality assurance equipment, all those devices that could be integrated into the production equipment and that could make the processors more efficient, more zero defects approaches, or you know, all the technologies, all the hardware related to the manufacturing systems that could be integrated into our machines. So this will be included here. In the third domain, we are covering all the technologies around the Industry 4.0, including digital, virtual, and using of information inside the company, but also along the value chain. We could include here aspects like virtual reality, augmented reality, cybersecurity, digital twins, or even how the information is flowing from one stage to the following in the manufacturing value chain. So all those technologies and how they are covered into the companies could be included, are included actually in this domain. The fourth domain deals with human-machine collaboration. And here we are not thinking only on the human-machine interface, but also in those technologies that could make the working places more attractive, more safer, and more inclusive for the different kind of skills. So all those technologies that could contribute to the human-robot collaboration, for example, or that could contribute to provide the right information to the operator at the right moment and in the right way will be also included in this human-machine collaboration domain. A fifth domain is the sustainable manufacturing. And originally we thought on this domain for those manufacturing technologies that could contribute to the less energy and raw material consumption during the machining, during the manufacturing. But we would like also to include in this sustainable domain, this sustainable manufacturing domain, all technologies around reusing, recycling, remanufacturing. You know, the circular economy applied to the manufacturing scenario could be also included here. And finally, this is the sixth domain. We call it customer-based manufacturing. In this domain, we are including all those relationships and interactions that could come from the different stakeholders of the value chain, from the raw material provider up to the end user, the technology suppliers, and all those business opportunities that could arise from this collaboration on the value chain. Okay, so as you see, these are our 6 technical domains. Of course, the SMART projects could deal with several domains at the same time. We are not asking to the projects just to focus on a specific domain, not. But as you will have seen, we have defined the technical domains quite wide and broad in order just to follow this bottom-up approach and to be able to respond to the needs and priorities of the companies. Okay, so let's go now to the 4th call for projects that we have opened in September this year. As I was mentioning, the eligibility criteria that Eureka defines for the clusters appears in this slide. So the consortia has to be at least 2 industries from 2 different countries, have to be innovative and market-oriented, the projects, and the project have to have civil purposes. I mean, not military projects are allowed. This is one requirement coming from the Eureka program. And finally, the budget in the consortia has to be a balance between the participants and also the countries involved in the consortia. That means, of course, we can have a different participation of partners and countries in the budget, but this has to be more or less well justify the activity and participation of the different partners. In SMART, we are following 2 stages approach for submitting our proposals. As you know, we are still in the project outline. This project outline is the first stage. I have to say that this is not a go, no go phase. So all the projects will be evaluated in a positive way. And the idea is that our feedback will be their recommendation and suggestions, how the proposal can be more successful into the full project proposal stage. This full project proposal stage is the key one, is the critical one, because this will, the evaluation of this full project proposal stage will determine if the projects are granted with the SMART label or not. But in this project outline stage where we are now, we will provide you and the applicants our feedback on how to improve the proposals. This is not a go, no go phase, okay? Typical figures, mean figures of the SMART projects, a budget from 4 to 6 million, but of course we have also a project from previous calls with 1.5 million euros of budget. So this is just it. Please take these figures as a mean values or an approximation of how the budget, the participants are usually in our projects. But of course, it can be different in your case. No? The consortia are formed by 6 to 8 participants with 2 to 4 countries and project lasting 2 or 3 years. This is the more usual. But I repeat that this is something that can vary. And now in our 4th call, this is the deadline, important dates just to take into account. At first, the deadline for the PO, where you will have to present these 12 to 15 pages explaining the idea, your approach in a general basis. The deadline is the 14th December. By the 25th of January, we will send the coordinators and the applicants our feedback on the evaluation of the PO. I repeat that it's a positive evaluation always. And the important deadline is the 24th of March the next year, where we will have to receive your full project proposal applications. And after that point, it's open an evaluation of the full project proposal, and along with the national public agencies, the decision on the final SMART label to the positive evaluated projects is going to be communicated to the applicants by the 17th of May 2021. So after this date, the 17th May, those projects that are granted with the SMART label will have to go to the national public agencies and then negotiate or request the national funding for supporting you. Of course, during the PO and during the FPP phase, we request to all the applicants to keep a close contact with your national public agencies to be sure that the proposal can be granted, can be supported by national instruments, and the topic that you are focusing in the proposal is covered by your national programs. Of course, from the SMART office, we will provide also our support in helping you to clarify these aspects or to establish the contact with the national public agencies. And this is my final slide. Some hints for preparing successful SMART projects that we have seen from the previous calls. First, as I repeat, our projects have to be close enough to the market exploitation. So think always in an industrial application and how you will implement these technologies in an industrial scenario. This is really important, I repeat. Second, think on the soundness of the concept, and as far as possible, try to clarify and quantify expected objectives. So this is important. Try to define SMART KPIs, thinking on SMART on a specific, measurable, attainable, relevant, and timely indicator. So this SMART concept KPIs fits pretty well with our SMART cluster. So, but have this in mind. It's important. These KPIs. Of course, your consortia should have relevant industrial partners. I mean, the industrial participation is important. And as much as possible, try to engage SMEs. From the Eureka perspective, it's always important to create impact into our small, medium enterprises, because we think that maybe they would be the more needed companies in the implementing new technologies, transferring new technologies or new manufacturing approaches in order to improve their competitiveness. So try to engage SMEs. Check with your national program agencies if there is any specific requirement in terms of participation of SMEs, or how the research centers and universities are being funded at your national program, or I don't know, how close the technologies you are targeting should be close to the market or not. I mean, the different countries participating in our cluster could have a specific requirement for their national programs. And finally, second is a sound exploitation strategy and clear results as much as possible. Also the risk analysis, if you're able to do that, considering the current situation of the COVID-19 and also the maybe the future evolution of the market in short term or medium term. So take this into account, this risk analysis. And then for finishing, just take advantage of the SMART office or the SMART brokerage events. In our website, you will see the project looking for partners. That is one area of our website presenting proposals that are being in preparation and are looking for partners. So this is open to you just to engage with them. Important point, double check the deadlines for the FPO and mainly for the FPP phase. And finally, of course, from the SMART office, we are always open and transparent and trying to help you to provide our best service to you. and just to be also the bridge to contact your national contact point or to solve any doubt or any questions you could have. So please feel free to contact us. We will be more than happy to provide our feedback and our help. So that was all from my side. You will have this presentation available after the meeting, and of course this webinar is being recorded, so you can follow, you can send to your colleagues, or you can make use of it in case of need. So thank you very much again. Pleasure to have all of you in this event, and I will give the floor now to Aritze Arteche from Smart Office as well, the program coordinator, who will introduce how the event is going to continue. So let me just stop sharing.
Hi, good morning, everyone. Thanks for your explanation, Joseba. And just before going on the next point of the agenda, which is the pitching session, we already received a question regarding your explanation. We are being asked if partners from the interested countries also receive funding. Can you explain that to the audience, please?
Yes, of course. What is important is that the different countries, the countries have to be Eureka, within the Eureka community. This is important. And what is also important is that the different countries have to set up national program initiatives on advanced manufacturing. So the partners involved in the project, in the SMART projects, could request national funding to these national programs. So this is important. But in the case of interested countries, of course, you can request the funds from your country, but if the country set up the corresponding national programs. Okay. I hope it is clear enough.
I think that was enough. Perfect.
Thank you.
So we will go on to the next part of the session, which is the pitching session. Today, we will have 10 project ideas pitched on this event, brought here by different speakers. I will give them the floor one by one, and they will explain those project ideas to you in about 5 minutes each. After that, each presentation is already uploaded in our projects looking for partners section of the website. There in the screen, you can see how to reach that section in our website, and you can download any presentation to get all the ideas so that you don't miss any information. And the last slide of the presentation has always the contact information so that you can contact the speaker or the person who is in charge of that project idea. I also want to remind you that in this section, project looking for partners, we also have other presentation or other project ideas that have been submitted to us. Please check all of them, because there might be some that might interest you. And we also want to remind you that you can send your project ideas from now on until the FPP deadline phase, because a project can come up any moment between now and that moment. And last, after this meeting, most of you have already registered, all of you have already registered in our B2Match tool, so that you will be able to have B2B meetings with most of the speakers, because most of them are also registered in that tool, and you can have bilateral meetings between you. How you have to do it, you have to log in with your user, click on the upper right hand side of the screen, meetings, and book new meetings as you can see in the screen. Remember that the meetings today will be 20 minutes long, and you will be also able to hold meetings until next Friday. From tomorrow until next Friday, meetings can be 1 hour long. If you, of course, if you finish the meetings earlier, you can finish them earlier. That was all from my side, and I'm going to start. Giving the floor to each one of the speakers. First, we'll have Pablo Romero from Aymen, Spain, talking about zero defect manufacturing of fiber reinforced thermoplastic parts.
Okay, thank you, Aritz. Do you hear me? And can you see the presentation?
Yes, we can hear you and we can see your screen. Okay,
great, thanks. Thanks, Aritz and Joseba and Smart colleagues for giving us this opportunity to present our company and our idea in this forum. So let me just briefly talk about Aymen. So we are a research and technology organization located in the northwest Spain. We are about 240 employees and carry out in the last 10 years nearly 700 projects, R&D projects, focused on mainly 7 research lines. I would highlight high performance materials. We are working on carbon fiber reinforced polymers, with a special emphasis on thermoplastics, with in situ consolidation manufacturing schemes. We also are focused on smart, flexible, and sustainable manufacturing. This research line is very transversal and supported with our capabilities on advanced robotics and sensors, such as artificial vision and fiber optics and digitalization capabilities. We are also working on laser-based manufacturing, laser cladding, surface modification, welding, and also additive manufacturing, as you can see in the bottom right image. We also have low power laser technologies for micro and high precision manufacturing, for micro additive manufacturing, and also surface modification for example, improve wettability or other functions, surface functions. And finally, environmental technologies focus on waste valorization. So in the H 2020 program, we are coordinating 20 projects and are partner in 34 more projects on several topics. Okay, so talking about our idea, our vision is to develop a one-shot manufacturing scheme based on cognitive and highly adaptive robotized automated tape laying head to produce or to come up with a zero defect manufacturing of thermoplastics. So in order to do that, we need to develop highly controlled heat input. If you can see in the image, the incoming tape needs to be heated, but also the substrate. So we need to develop highly controlled heat input in order to guarantee the correct state of the polymer in order to acquire this consolidation. So the motivation is to increase the potentials of thermoplastics because they can by in situ consolidation, of course. We will remove the the autoclave processes for thermosets and thermoplastics, so make the process more simple, but also and take advantage of the reparability and recyclability of thermoplastics. that will pave the way somehow to more sustainable transport structures. Regarding the content of the project, we emphasize here the development of this highly flexible heating system. Can be laser, but also other sources such as flash lamps. We need also the technology to develop this closed loop control in order to have this adaptive manufacturing scheme. So we envision here the use of artificial vision and hyperspectral technologies, and also the inline inspection in order to detect these voids and possible delaminations during manufacturing. And also another content will be development of new fiber reinforced thermoplastic tapes. Regarding outputs, there is not a lot of technology for online inspection of composite during this manufacturing technology. So we see here a good outcome related to this ultrasonic detection or other technology. Other outcome is the zero defect manufacturing by in situ consolidation. I mean, this is the title of the project, but this is not achieved currently. So we envisage this outcome as a potential result. And the increase of manufacturing rate as well, since we are going to come up with more flexible ATL manufacturing processes, we will have more design space and more manufacturing or increased manufacturing rate. Impacts, I will highlight this flexibility to consolidate the thermoplastics in the transport sector, to introduce new complex parts in this sector and others, and also enhance on overall the possibilities of lightweight materials in different sectors. We see here a 36-month project, and talking about partners, we are mostly focusing ATL head manufacturers and fiber reinforced composite tape manufacturers. Machine vision we also have at AIMEN, but we are open to also to collaborate here. And that's my contact point. I'm open to talk to you, and thank you very much for this opportunity.
Thank you, Pablo, for your presentation. As we said, we hope that you get many contacts from this presentation, and that you can send us a successful proposal to our fourth call. Thank you. Next presentation is that made by Eric Flores and Jake from KTH Sweden, talking about the digital twins for improving sustainability in smart logistic systems. Good morning, Eric, and good morning, Jake. The floor is yours.
Good morning, thanks. Hopefully you get to see my screen.
Yeah, we do see your screen.
Great. Thank you. My name is Eric Flores. I am a researcher at the Royal Institute of Technology in Sweden. And I am very grateful to have this opportunity to present our idea, which we've named Digital Twins for Improving Sustainability in Smart Logistics Systems. Who are we? The Royal Institute of Technology is Sweden's largest technical university. I work for the Department of Sustainable Production Development, and we are focused on 3 research areas, of which I am a member of production logistics, led by Professor Magnus Wiktorsson. The core of our work really is that of helping manufacturing companies improve logistics competitiveness through smart technologies. And we do so through a sustainable perspective, which leads us to the proposal and the vision of our project. In this project, we wish to help manufacturing companies of the automotive industry develop a digital twin. And in particular, what we are targeting is services that can benefit operators, logistics managers, and factory management. How is it that we are going to do this? We are going to develop an AI-based model for material handling. that can meet both logistics KPIs, but also an impact on sustainability. In particular, when it comes to practical development, we wish that this project can contribute to shop floor applications that have to do with end-to-end digital twin. And we are targeting two aspects of a factory. One is material handling that happens inside the factory. And two, the transportation that occurs between a supplier and the factory itself, the interface. In this project, also, we are aiming to collaborate with automotive manufacturers on the one hand, but also with SMEs that are focused on the IT sector, in particular, those that have to do with the real-time location or AI software. What is the motivation for this project? We have seen an increased need of customized products in the automotive sector, and this has led to a fluctuation demand that is very difficult to cope for manufacturers. And the realization that we can no longer tackle these concerns with traditional ways of handling logistics, but that digital technologies may help to achieve this purpose. In addition to that, we see an increased importance in sustainability from government agencies, from corporate mandates, from customers, and also employees working at manufacturers. This is a very broad scope of what we are trying to achieve in providing a digital twin powered by AI that is contributing to how logistics is handled inside the factory and its interface. As part of this project, we envision developing, testing, and validating at the floor shop application, but also contributing with new developments of technology. We have outlined certain outcomes that can benefit manufacturing companies and IT companies. And I would like to highlight for those working on the AI application side that as opposed to what is currently being done, providing solutions to the customer end, we are looking towards the factory in itself. As far as the market impact goes, the KPIs that can perhaps contribute to a factory improvement, then we are targeting energy efficiency, make span, and delivery of products. But in addition to that, we're also targeting social, environmental, and economic aspects of sustainability. We're aiming for a 3-year project in which we are collaborating with all partners. This is fundamental for us. Currently, we have partners in Sweden in automotive and AI, and we have also partners in Korea. But we wish to extend our network, in particular if you're from the automotive sector, a supplier, or an IT company. I thank you all for your time, and I am very grateful to hear more from you.
Thank you, Eric. That was a great presentation. We will now go on with Lander Galdós from Mondragon University in Spain, and he will talk us about heat-assisted sharing and forming of complex shaped metal components using high-strength metals. Great long name, that one. Good morning, Lander. Thanks for joining us. The floor is yours.
Can you hear me?
Yeah, we can hear you and we can see your screen too, yeah.
Okay, so yeah, hopefully you enjoy this proposal and you can join us. So the title, as Harit was saying, is heat-assisted shearing and forming of complex shaped sheet metal components using high-strength steels or metals. Yeah, briefly, I'm from Mondragon University. We are like 75 years old, and I would say or define ourselves like very applied university, close to market, probably because we born from the cooperative movement, and we belong also to Mondragon Corporation Group. So this can be the explanation. In our research group, the Advanced Material Forming Processes Research Group, we do research in casting, forging, and sheet metal forming, including tube hydroforming, gas media forming. And we do have quite big industrial means for that and different characterization machines for material and contact characterization. So this is basically our introduction. Regarding the proposal, most of you probably are aware that we have a big challenge when forming high strength steels or high strength metal alloys with edge cracking. This is a reinforcement in DP1000. This is like a whole expansion cracking, okay, in a chassis component. So we want to solve this in our project to form and to shape complex shape metal components using these alloys. Okay, so the main objective of the project is to develop cost-effective and fast in-tool heating technology. Okay, for two purposes: the stamping of chassis components using high strength steels, but also to fine blank thick components and then bulk form them. So bulk forming of the sheet, okay, of the thickness of these fine blank components, okay? And to improve it, we want to use heat assistance or heating, okay? The motivation is to decrease this poor edge cracking and ductility of the materials using locally heat assistance, okay? We have different concepts, but one of them is using induction or using contact heating, for enhancing this, okay? And the important aspect is that we need quite a lot of power installed in the tools because this will be serial production and the technology needs to be embeddable in progressive dies, okay? We did some tests in our labs with contact plates and induction heating. So with both, we think both are suitable, but we want to go further with this to have the final concept. The expected outcome is to have new heating methods and hardware in the market for progressive dies, new chassis components using ultra high strength steels, and a significant decrease of the effective rate that nowadays are having the companies, to have new thick fine blank plus forged or formed through thickness formed components for the automotive industry, and at the end, we would produce complex components and which are lighter for the automotive industry. Okay, impact is very difficult to expect, so to measure, but we are aiming to provide a concept and prove it at least in 2 new products that will have a massive production, like more than 100,000 components per year. Okay, the project will start in January 2022. And will last 2.5 or 3 years. The consortium is quite defined, okay? So we have Teknorod in Turkey, that is a tier 1 doing chassis components and will be the leader. And Hacettepe University in Turkey too, that will be supplying and helping with the technological developments there. And here in Basque Country, we have LI, which is a well-established company, tier 1, doing fine blanking. And our role will be to help them with the technology development, okay? We do lack one key partner. Although we have a small equipment of heating, okay, we will need a partner that develops heat-assisted methods, okay, induction, cartridges, or laser, and that wants to work in this field to have a new hardware for embedding it in progressive dies. So this is what we need, basically. But we also want to include a company that aims to use the heat to improve any poor ductility forming process. And if it's a company in Spain, this would be nice because it would help us to balance the budget from Spain and Turkey. Okay. If you have any doubt or any idea, yeah, you can contact me. You have here my details, okay? And we can meet all the consortium for discussing your concept. So that was all from my side.
Thank you, Lander. Thanks for your presentation. Right now, it's Egidius's turn. Egidius Vanagas from Lithuania, from the Tulas cluster. Good morning, Egidius.
Good morning.
Can you show us your screen, please?
Yes.
Yeah, perfect. Gideus is going to pitch 3 project ideas, so he will take a little bit longer than the rest of the speakers. Gideus, the floor is yours.
Thank you. I would like to propose 3 projects, which is waveguide formation in silicon, laser pinning project, laser deep UV full harmonic polishing. Means all the project is related with laser processing, laser technologies, and I would like to introduce first of all Tulas cluster, and we have some products and services which is related for laser processing, laser technology, including laser itself and also laser tool. We have some companies which is really producing some parts of laser, some services for optics and optics itself. And also we have research development expertise in very wide range of optical devices and tools. And also our products really have some applications in medical, semiconductor, vision, space, security, defense, and others. So just here is our introduction, and first project is waveguide in silicon. It means we would like to have some feasibility study and proof of concept for waveguides formation in silicon and proof of light propagation in silicon and achieve the minimum quenching which is acceptable for device intercommunication inside the chip. Motivation is that we can make some more tight integration of optoelectronic devices in silicon chip, and can be very, very different, dedicated for a lot of very direct, very, very precise functionality of these devices. And we can do this interconnections between optoelectronic devices inside silicon and really quite fast prototyping of the devices in the case of drawing of waveguides in silicon. So expected outcome could be with modified silicon refractive index, and these channels could be suitable for light propagation. And we targeting in silicon-based microelectronics and optoelectronics with actually multi-billion market, and really we expect that our results could be useful for this market. We plan to start this project in summer 2021. So that is for waveguide silicon. And next project is for laser pinning project. We have all the competences, and really would like to start this even on our own expenses and risk this project to have some proof of concept and also some feasibility study for femtosecond laser pinning technology. And this also motivation is quite strong, because this is really maybe not so big areas. We can make some hardening of the surface of the metal, but actually we calculate that in the case of this successful solution, we can cover in the range of square meter per hour surface of some hardening objects. And also, if in the case of a successful solution, we can start to make some prototyping of device, and also some recipes for this hardening laser pinning process. So also the market should be quite big. It means that mainly some kind of automotive industry and any industry which is really based on some material sustainability along the time, and some hard working environment. And also this is multi-billion size of market that we can really expect in the case of successful solution. Number 3, laser deep UV polishing. Also, this is feasibility study and proof of concept. We working also with femtosecond laser force harmonic polishing technology, and here we can make this technology for micro optics application. And really this micro optics application is really quite common for, and have more and more important role for optoelectronics industry, and really could be a lot of application for optoelectronics multi devices. Also, we plan to really, in the case of proof of concept, we plan to make some laboratory system and also prototype system development. So this could be outcome. Really, we plan this outcome for prototyping of the system. Also, really, this impact for the industry could be quite big, because we have a lot of possibilities to fit with our technology and help microelectronics industry to improve the quality of devices, which is based on this micro optics parts. So also we plan to do this in next year, start next year, in the case of good really relations. And maybe also we have for the moment for partners which really accept our ideas. This is Tuulos cluster, Center for Physical Science and Technology of Lithuania, Vilnius University Light Conversion Company, and we are looking for the partners around the world, and these partners could be academic industry or some investors which is interested in development and commercialization these ideas. So that is it. And
Thank you, Egidius. That was perfect. You did 3 pitches in 10 minutes. Great.
okay, thank you.
Thank you. I hope you have many contacts after these pitches and that you can send us some project ideas in the future. Next one on the row, once that we got this halfway in the pitching session, is Jefford Humes from Nano Intelligence Technologies in Canada. First of all, I want to thank him because he is joining us from Canada. It's 5 o'clock in the morning right there, and it's a big effort for him. Hi, Jefford.
Hello, good morning.
Morning. So you're going to talk about graphene enhanced bioplastics. Is that right?
Yes, that is correct.
All right, perfect. We can see your screen, so the floor is yours. Thank
Hey,
you.
good morning. Good morning, everyone. Thank you for the introduction, Ortiz. My name is Jefford Humes from Nano Integris Technologies. Today, I would like to present our proposal for graphene enhanced bioplastic. Let me tell you a little bit about the companies that I represent, Nano Integris Technologies and Raymore Industries. Basically, our personnel there. I'm the Director of Research and Business Development. We also have modeling and plasma system specialists, directors of quality, and various research scientists, engineers, and technicians. But let me tell you a little bit about our business. As Ortiz stated, we are located within a suburb of Montreal, which is in the province of Quebec in Canada. And Nano Integris Technologies was created specifically to purify and separate single-walled carbon nanotubes by electronic type, meaning that we can create them, enrich them to be very high purity semiconducting or metallic in nature. This functionality has since increased, leading to the supply of 99+% purity semiconducting and metallic products in solution or in solid form. And this scope of the supplied nanomaterials has grown to include graphene, boron nitride nanotubes, small diameter nanotubes, dielectrics, multi-walled nanotubes, and transparent conductive inks for various types of applications. Now, what I'm going to mainly talk to you about is another proficiency that we developed from our parent company, Raymore. They specialize in the use of an inductively coupled plasma reactor to synthesize high purity single-walled carbon nanotubes and few layer graphene at commercial levels that can also be used for numerous types of advanced applications and technologies. So what is our main project goal today? Well, today we would like to discuss the synthesis and commercialization of a graphene-enhanced composite material, which can be utilized for 3D printing filaments of bioplastic, allowing for biodegradability and enhanced mechanical and electrical properties. Why is this project necessary? What is our motivation? I would say it's basically twofold. First of all, there is an environmental benefit. Switching all plastics to biodegradable materials would reduce greenhouse emissions by at least 25% in the US alone, according to various studies, with even greater worldwide impact. Secondarily, our motivation, of course, is market potential. The global 3D printing materials market for plastics is estimated to grow from $687 million in 2019 to $2.1 billion by 2024 at a compounded annual growth rate of 26% during the forecasted period. And bioplastics itself are predicted to control 40% market share by 2030, making bioplastics a potentially $324 billion enterprise, according to the European Bioplastics Study. So the developments that we're looking to be made in this project is a selection of target polymer and graphene components, a stable, efficient, and cost-effective compounding technique, a manufacture of the 3D filament itself, and finally, a 3D printing of functional graphene bioplastic. Our expected outcomes are very similar. We want to develop a graphene-enhanced bioplastic composite, cost performance material optimization, commercial scale manufacturing strategy, and then an establishment of a manufacturing, marketing, and consumer network. What do we believe to be the impacts? Well, we want to attract 3D printing filaments and adaptive manufacturing markets with graphene functional additives. Some of the benefits, some of the industries that we believe would benefit from this are the electronics industry with printable and flexible electronic sensor applications, the medical industry with customized medical products, tools, and devices, industrial industry, primarily additive manufacturing with faster product development cycles, simplified and significantly less expensive supply chain logistics, easy to change or modify a product, reduction of production waste, faster and less costly product certification process, and then materials and energy savings. Our schedule roughly is a 2-year schedule involving experimentation, scale up, manufacturing and testing, followed by a desired for commercialization. Our partners, now we're not currently a part of a consortium for this, so we're really reaching out for various types of partners to facilitate this project. We're looking for compounding specialists, additive master batching teams, plastic property analyzers, and then industry sensitive marketing teams, and of course, investors. If you're interested in being a part of this project and joining our consortium, please do not hesitate to reach out to me. My name is Jaford Humes once again, and thank you for your time.
Thank you, Jefford. That was awesome. I think that you can go to bed right now after this event. Thank you. Right now we're moving to Turkey. Ibrahim Güzel is there from Arçelik company, and he's going to talk to us about adaptive process implementation in additive manufacturing technologies by artificial intelligence. So there are quite a lot of I can't find the word. Ibrahim, the floor is yours.
Hello, could you hear me?
Oh, the connection is not very good.
My screen, can you see my screen also?
Yeah, we can see it, yeah.
My camera, I want to close my camera because connection speed is not well. It's not problem. I want to continue like this. Okay, could you hear me?
Yeah, we can hear you, but not very well.
What now?
Yeah, go on. And if we see that
okay.
the connection is not very good, we will have to continue with the next ones.
Okay, our project idea is adaptive process implementation in additive manufacturing technologies by artificial intelligence. I'm working in Arçelik company more than 15 years. My company is one of the biggest home appliance sector company in Turkey and is a part of the Koç groups. We have more than 30,000 employees, and we have 23 different production facilities in 8 countries. My responsibilities about the R&D. I'm working in R&D center, and my responsibilities is for the additive manufacturing technologies. So with our project proposal, we want to make a new adaptive systems to understand the possibilities of the aim and to build solid structures with the best quality and best material defect, not exactly affected. We have a selective laser sintering machine. It's a polymer-based machine in our laboratory. So we are using virgin powder and overflow or used powder mixing. So with this mixing, the result of the parts is not fitted our needs. Some weakness problem, some cracking problem, or surface quality is not good as our needs. We estimate that this is related with the ratio of the powder, mixed powder, and used powder is not well mixing, because this is manual operation. So with this project, we want to develop a suitable visual control application by using artificial intelligence. Then the mixing ratio can understand by automatically, and the process parameter of the machine is fitted to this mixed ratio, and the parameter can result to good part result. Problems or weakness of the part can be eliminated. So why this project is necessary? This project is important because the spare parts or the prototypes, the facts can affect our all R&D process. The result of the parts can sometimes make the problem about the materials, or can postpone our projects. Also, the quality level is not fitted. So with this project, we want to eliminate these problems. Configuring a best fit control application with the artificial intelligence systems, this mixing ratio and sensor or visual thermal camera, etc. Detection system can perform, and then the result with the development of this kind of platforms, we can use our machines. Also, this kind of manual operation machines can use these systems. So in this project, the algorithms or the components and that other development issue can easily transform the other machines also. So as this scenario, as I explained, virgin powder and overflow mixture is made manually. So the category of the production powder can determine it by visually or not understand very well. But to be scenario with the mixture, categorizing is detection with the visual or inline production systems. So the detected mixture ratio, according to the detected mixture ratio, the parameter, machine process parameter, can choose, then the final product is produced according to the best fitted area. So with these systems, we are expecting the quality problems can decrease, resulting saving time, production time, energy, and printed material powder can also using it very well levels. Then scraps can be decreased. Also, because of the non-used material can problem for the environmental issue, with this process improvement, we can result the good environment solution. Optimum process parameters can also help for the or serial production spare part application also. Velocity of the process can be performed at Arçelik facilities. We are located in Istanbul, Çayırova location. In our garage laboratory, we have two different SLS polymer machine. Also, we are experienced about the FDM or other project technologies too. So at this impact, we can modify our machine accordingly, and we make some trials. So we're searching partners which is ability can understand this material property classification and understand the good levels of the material. Also, the partners should be sensor-based or camera-based systems generator to understand the best fitted parameters or and situation of the material. Then communication of the machine with this sensor-based system or visual control system, and this communication integration with the machine and the parameter selection manual system can be searched. With this aim, we need partners too. If you want any detailed information, please contact me and my colleagues from the our project office, Cansu and Abdurrahman. Please do not hesitate to contact with me. Also, my colleagues too. Thank you very much.
Thank you, Ibrahim. We had a little bit of noise in the background, but finally, I think the presentation was good. And finally, we're moving to Ireland with the IMR team. Fergus Gilligan and John Mulaney are going to introduce us two project ideas that they have prepared. Good morning, Fergus. Good morning, John. The floor is yours for you to begin. Yeah.
Morning, Aritz. Thank you for that. So the project I'm talking about here today is A Path to Zero Carbon. It's about improving the energy performance of manufacturing facilities. About Irish manufacturing research, we're a not-for-profit research and technology organisation to help Irish manufacturing innovate. We're about 85 people, mostly researchers working in data analytics, industrial Internet of Things, sustainable manufacturing, intelligent buildings, automation, advanced control, circular economy, software engineering, amongst other things as well. So the proposal I'm proposing here today is around the application of renewable technology and AI to support the demonstration of a zero carbon building. And the motivation of this is to develop intelligent energy services to demonstrate reduced carbon for factories, especially legacy factories. The content of this then is around the application of AI to monitor and enable advanced real-time optimization through integration of intelligent metering and control systems. It's also to include research into federated machine learning and fog compute architectures that can integrate your energy and natural resource consumption and response strategies into productivity and consumption and behavior for factories. It's also about developing energy-aware buildings by jointly optimizing consumption costs, occupancy comfort, and CO2 reductions, and then looking at connecting digital technologies to integrate that distributed renewable energy sources with bidirectional charging functionalities to enable a neighborhood optimized storage, including the management systems then for optimal integration, flexibility, and interoperability with the grid itself. The expected outcome of this is the development of an advanced analytics and AI platform to optimize factory performance for energy. Included in that would be a digital twin model for scenario planning and impact analysis for energy optimization, and a demonstration then of how an energy-aware building can integrate with renewables and local storage in order to optimize performance. The impacts of this we expect to see are a demonstration of an autonomous optimization of energy-based KPIs for a building. To have a national exemplar showing how a complex building environment such as a factory can be integrated into a local grid network, supporting a predominantly renewable energy-based national grid with a demand response service, and a methodology to demonstrate how one would approach an improved carbon footprint for a legacy building. We envisage this to be a 2-year project, potentially 2.5 years. In terms of the current consortium, IMR have a manufacturing facility in the National Science Park in the middle of Ireland. We propose to use that as a location to test out the solutions and to test out the neighbourhood integration. We will also support the development of an advanced analytics program. We also are working with Eaton Corporation, who will supply power management infrastructure and expertise, and they will also be developing intelligent power management services for both within the factory and at the neighbourhood level. They also will offer one of their office buildings as a test site for integration of renewable energy and electrical vehicle charging facilities. In terms of a partner search, we're looking for partners with expertise in implementation of energy management solutions for complex environments such as these. We are open to other use cases as well, and obviously given the call, we have a particular interest in attracting any SMEs to join this consortium as well. In terms of contact information, that's myself. It's Dr. Fergus Quilligan. I'm the Director of Analytics in IMR. That's fergus.quilligan@imr.ie. That's all. Okay, thank you. And I'll hand over to John then for the second presentation from IMR.
Thanks, Fergus. John, you have to unmute yourself.
Okay, good morning, everybody. Can you see my screen?
Yes, but it's not full screen. But
okay, we'll be in a second. Now.
It is right now. Yeah, thank you.
Okay, thank you. Good morning, everybody, and thanks for a few moments to share this project with you, which has got to do with the design for manufacture for products in a clean room environment connected with a molding, with an injection molding operation. So Fergus has introduced who we are. So just to tell you, just to minimize a couple of things here, sorry. So we are working with a highly experienced tooling and injection molding company, which has been in operation for the last 64 years and has a very broad depth of experience in creating molding tools and also in molding a vast range of plastic related products. And right now they are expanding into a new clean room facility and into a whole range of product services for that type of facility. That does create an opportunity for us to cooperate with SMEs in producing matched products and production environments. This is to create the ideal environment for particular products, for new products that SMEs may be thinking about, but may not yet have got to an optimized production format. So we want to use with them design for manufacture principles to create the best possible product in the best possible environment, and to work out what is the ideal scenario for that. So the reason for this is because we're aware of the growing demands in relation to sustainability and in having products that are optimized in terms of energy use, in terms of cost, and in terms of quality. And we want to explore this more with our client. We are willing to engage in experimentation in terms of the design of the product, in terms of prototyping, in terms of small batch production, in terms of creating the ideal environment, as we say, for that, with the view to ramping up to a production level that is demanded by the product. So in terms of content, we do envisage starting with a concept and finishing with a product in a suitable working environment. So we are hoping that that will draw in clients that will enable us to leverage our technical knowledge, the technical knowledge of our client as well, to take on new challenges and to enable those who maybe be struggling around the whole production chain on how they're going to optimize production of that product in getting ready for market or for a volume scenario. So the expected outcome is that we would be able to work to de-risk any of the opportunities or any of the concerns that are there around the production environment, around the impact on the product, and assuring the quality of the product that is finally designed and produced. To look at the integration of whatever ideas or other technologies may be involved in the production of that product, and to include that into the development and the design, and to end up with something that is commercially ready. So the impact through this project, then, we hope, is that we will be able to accelerate from a concept to reality right throughout the product and the process development, and to open up access to experienced injection molding resources to provide that reality and to deliver a rapid route to a volume production. So we're hoping to work on this over a 24-month basis, and the type of clients we're looking for would be either those with a good product idea or those who are looking to get into a high volume manufacturing scenario. So my colleague, Dr. Carlos Garcia, is listed here as the contact, and we would be very happy to speak with any of you who are interested in that. So thank you for your time.
Thanks, John. With your presentation, we've come to the end of the pitching session. I hope all the people are interested in the pitches that you have done, and I'm gonna proceed to close the pitching session. I'm gonna share my screen, which I have been told that I didn't do before. John, can you see my screen? All right. What about now? Yeah, is it okay? Yeah.
Yeah.
Thank you.
Yes.
So I wanted to remind you that these project ideas that you heard about are available in our projects looking for partners section of the website. You can see there how to reach it. You have to go to submit your proposal, and the last section is projects looking for partners. All these project ideas are available, but there are also more project ideas that might be of your interest. And we are receiving more. As we were having this session, I already received 2 more project ideas. For those who are attending the meeting and not as speakers, if you have any project ideas, you can send them to us and we will upload them to share them with all our audience. Remember that the contact information is available in the last slide of those presentations. But the main aim of this event was to provide the means to have bilateral meetings between the speakers or the different attendees to the event. We have almost 170 people registered, and remember that you can have bilateral meetings between you using our B2Match tool. The tool will be available until Friday 13th. As I said before, today you will have 20-minute long sessions or meetings that can be booked. And from tomorrow on until next Friday, they will be 1 hour long meetings. You have to log in to the B2Match tool using your username and your password. You have to click on meetings on the upper right-hand side of the screen, and later on book meetings. Some of you already have accepted meetings. Some of you already have pending meetings. You only have to accept them or reject them. We hope that you have fruitful meetings over there. One last remark before closing this event. Do not forget to contact your national funding agencies, because they will give you hints on how to form the consortium. The funding rules are very different from each country to another, and they might give you advice on how to form the consortium in your country. I'm not going to go into detail, but there are some countries that won't fund research centers or universities unless they are subcontracted. Other ones will give direct funding to those entities. So please contact your national funding agencies for that. And as Joseba said before, to see if the topic that you are focusing in is one of the national priorities that they would fund. Last but not least, you can also contact us for any doubt you may have in all the process. First of all, in the PO phase, and afterwards in the FPP phase. You've got our contact information there through our email, info@smarteureka.com, and there are also many different possibilities to contact us through our website. It's 11:28 by my watch, and we almost nailed it. Thank you everyone for being there. We will send you the presentations that we had today, the one that Joseba used to explain what SMART is and how the fourth call is going to work, and this one explaining how to reach the project looking for partners section, and how to ask for B2B meetings. That was all from our side. Thanks for being there. I hope you enjoyed the event and that you've got many ideas to send proposals for both the PO phase and the FPP phase. Thank you. That's all.